Hey guys, Mr. Bowman here. Today's learning objective is in pink and we are learning to use bearings to solve problems. And I've underlined bearings because that's the key word today. Bearings, they have a relationship with angles, and historically what bearings have been used for, they were used in earlier days where modern technology wasn't able to help the navigation systems of boats. These boats could only really use a compass to navigate around the world, and the bearings does get derived from compass. So what these boatsmen could do is they always had that reference point of north, which they could figure out from the compass. And let's say maybe they're at point A, and that direction there was north. And let's say they were trying to navigate themselves to point B. They needed to figure out, well, in terms of the compass, what angle did they need to travel towards to get to B? And the number was a bearing, and I'll get into that in a little bit more into this example. So let's say they're trying to travel towards this direction. And the cool thing about point B, well, north is in the exact same direction. So what you end up getting is you end up getting a set of parallel lines. So these north lines are actually both parallel to each other. And it was a practical use of the parallel line rules and other geometry rules to calculate the angle or the direction that they needed to travel. So let's change pink color. Let's get into yellow. So let's say they needed to travel on an angle of 105 degrees to get to point B. So going from A to B, they needed to travel at a bearing of 105 degrees. Well, let's work backwards. So maybe you're at point B and you're trying to get back home, you're going to point A. What bearing would you need to use? And this is where it's slightly different. So it wouldn't be this angle here. And the reason being is because the bearing was always relative to the clockwise direction or angle. So what we need to do is the bearing from B to A is actually this angle around here. And we'll just get into this example and then we'll get into two more to wrap up the video. But to find this angle, let's say we needed to find angle X. So angle X, well, because it's a parallel line rule, 105 and X, they are co-interior to each other. So meaning they need to add to 180 degrees, which means X was equal to 75 degrees. And that's because they were co-interior to each other. Now that we have angle X, so we know X is 75 degrees, we can use the angles around a point to find the bearing. So let's call the angle we're interested in angle Y. So we know that 75 plus Y, that has to come to 360 degrees. And using a bit of algebra, so that means Y is going to be equal to 285 degrees. So that means the bearing to get from B to A was 285 degrees. So the key thing I'm looking to emphasize here is and I forgot to write actually, so the reason for that last one, angles around a point. So we're using that rule, they sum to 360. So the key thing I wanted to emphasize is the angle has to be in a clockwise direction. And these two north points, they're going to be parallel to each other, which means we can use existing parallel line rules to solve problems in relation to bearings. Okay, so that was our first kind of introductory question. Let's get into a couple examples. So our boaties, so they're currently at angle or position A, and they're trying to navigate themselves to position B. So they're trying to go along here. We've been asked to find, well, what bearing do they need to travel at to get between these points. So I'll reveal some more information that can help us. So we know, well, there's a set of parallel lines. We know those are parallel, and they're both in the north direction. And the only other bit of information we're given is we're given that angle had a bearing of 45 degrees. And typically when it's less than 100, we actually write 45 degrees. So that means to get from angle A to B, that had a bearing of 045. How do we get the backward direction? How do we find the bearing if we're going backwards from B to A? So similar to the first question, we're looking for this angle, which we're going to call Y. And to find that, we need to find that angle there. So angle X is what we're first interested in. And we know that 45 degrees and X, they are co-interior to each other, which means they need to add up to 180, which means X was equal to 135 degrees. And my reasoning, co-interior angles sum to 180 degrees. Now that we have that, so we can get rid of the X in our diagram and we can put it in, put 135 in. Now that we know that, we can go ahead and figure out Y. We do know Y and 135 degrees, well, they have to equal to 360 because they're around that point, point B. So we can use our algebra to figure that out. So that's going to be equal to 225 degrees. And that means, and the reason behind that, and I'm going to write out fully this time, angles around a point they sum to 360 degrees. So that means, back to our diagram, if you were traveling from A to B, so you're going in this direction first, you'll be traveling at a bearing of 45 degrees. If you're going back home in that direction, you need to be traveling at a bearing of 225 degrees. Okay, we'll do one more example. And we'll use the blue pen, I think. So our last example. Okay, so here's our north line. So this is point A. And let's say this time they're coming from point B here. So we know the bearing from A to B, we know that's going to be 275 degrees. So to get from B to A, they must travel at a bearing of 275 degrees. Well, what would it be to go the other direction? So what do they need to do to go back there? And similar to the previous questions, we're just going to be doing opposites. So firstly here we need to find X, and we need to find the clockwise direction, which will be Y. So our first step for X, well, we know that X plus 275, well, that has to equal to 360 degrees. And that means X will come to 85 degrees. And that's because angles around a point, I forgot to write angles actually, angles around a point sum to not 180, definitely not 180, 360 degrees. Okay, now that we've done that, we can go ahead and get rid of X from our diagram because we know that that's a bearing of 85 degrees. And we can figure out Y using our parallel line rules, our co-interior rule. So we know that Y plus 85, well, that has to come to 180 degrees, which means Y was 95 degrees. And that's because co-interior angles, they always sum to 180 degrees. So hopefully you found this introduction video to bearings useful. We went over some basic questions. Let's see if you can apply these skills to harder scenarios. Thanks for watching, guys.